Sequential sampling models of choice, such as the drift diffusion model or DDM, typically rely on subjective estimates of overall value. Most such models do not include information about individual attributes. However, previous work has shown that the attribute composition of choice options does impact choice behavior. Here's an example paradigm. First, participants rate each of these foods in terms of their overall value. How much would they like to eat it as a daily snack? They do this individually for a variety of options. Then they move to the next task in which they rate simply the pleasure of eating that option. They do that for all options. Then they move to the next task in which they rate simply the nutrition of eating that option. These, of course, are counterbalanced across participants. Next is the choice task, in which participants see two different options on the screen and they simply click on the one they prefer and then state their confidence about their choice. Multi-attribute decision-making typically considers that value equals the weighted sum of the attributes, so that overall value is the sum of the measurement of an attribute times the important weight of that attribute across all attributes. Previous work has shown that attention allocation to a specific attribute momentarily increases the importance weight of that attribute. Previous work has also shown that attention allocation during a rating task is not necessarily the same as that during a choice task. This poses a problem because most models of choice use overall value that was obtained during the rating section to predict choices during the choice section. Something else that's been recently shown in the literature is the effect of what's called attribute disparity, or basically how dissimilar the attribute composition of the choice options are. Shown here graphically, if you consider a two-attribute state space where each dot represents an option, choice 1 has a pair of options with high disparity, choice 2 has a pair of options with lower disparity, so that even though both of them have the same value difference, overall value that is, they have a much different measure of choice disparity. So shown with a concrete example, this participant believes that the overall value of carrots, ice cream, and brownie are all pretty similar. However, the disparity of carrots and ice cream are much higher than the disparity of ice cream and brownie. This disparity variable has a clear impact on choice behavior, as shown here, pooled across 6 previous datasets. The impact of both value difference and choice attribute disparity on choice consistency and response time are both significant. In this study, we tested 3 different models. One is the standard basic DDM, which uses overall value estimates. The second model is a similar format, except instead of overall value, it uses information from each of the individual attributes independently. And the third model is a sort of hybrid in which the information about the overall value and about each of the individual attributes all independently contribute to the drift diffusion process. Shown here, the qualitative patterns in model 3 match the empirical data much better than model 1 and model 2. But to formally test this, we did a quantitative model comparison in which we fit the data from each participant individually under each of the models and then compared the output. Shown here is the probability that each model was best per participant as well as across the population, and model 3 clearly dominates the other models. Finally, we did a test of model recoverability in which we simulated data under each of the models and then used the same model comparison procedure. And as shown here, the diagonal of this matrix, most of the data was appropriately accredited to its true generative model. In conclusion, we showed that a DDM that contains information about individual attributes along with information about overall value outperforms either alone. And we suggest that researchers might consider using individual attribute ratings in addition to overall value ratings, enabling to better fit ratings to choice data. Thank you very much.